Hey guys, Mr. Milton here. Today we're going to look at slope notes. At the end of the video, you should be able to find the slope of a line from a variety of given information. Okay, so lastly, video we will look at rate of change, and slope is basically rate of change without a label. Okay, so slope is going to be the change in y over the change in x. Okay, or another way we can write it is rise over run. Okay, very similar to rate of change. So as we look at finding the slope between 2 points, it says if the temperature outside was 40 degrees and it is now 58 degrees, what was the change in the temperature? Well, we could find that change, and we'd find that change by saying, okay, well, it's 58 now, and it was 45. 58 minus 45 is 13. The difference between this is the change, difference, change. Okay, and so we'd say the change is 13 degrees. Okay, now if we have 2 points, x1, y1, and x2, y2, what is the change in each coordinate? When you answer this, you are finding slope. And here's our formula for finding slope. We'd say the formula was y2 minus y1 over x2 minus x1. Another way you can write this is just saying y1 minus y2 over x1 minus x2. Okay, in both cases, notice that the important part is that you have the same x and y from their coordinates written first. Okay, so it really doesn't matter which direction you write it in. But you must be consistent. Okay, if I start with y2 first, then I have to start with x2. If I start with y1 first, then I have to start with x1. Okay, so let's look at some examples. It says find the slope between 3, 5, and 9, 8. Okay, so as I look and I set my thing up, I always think it's a good idea, especially in the beginning, just to label your points, x1, y1, x2, y2, and then follow the formula. y2 minus y1 over x2 minus x1. Okay, all that from those points. 8 minus 5 is 3, 9 minus 3 is 6. And then once we get to this answer, we want to see if we can simplify all the time. So we want a simplified answer. Okay, so here I can say that we can simplify, take 3 out of each of these. 1/2. My slope for this problem is 1/2. And M stands for slope. You'll see that a lot. Okay. Looking at our next problem, we have x1, y1, x2, y2. And again, it does not matter which order I find these in. It really won't affect anything. So this time I'm going to switch it up and do y1 first. So if I do y1 minus y2, and notice that we're subtracting a negative. Because we subtract a negative, that means we have to add 8. Okay, we'll actually erase that and do that. So we're subtracting a negative minus negative 8 over negative 3, x1, minus 1. Again, subtracting a negative. If we subtract a negative, that means we're adding 2 plus 8. And I'll just do this minus 1. Okay, so 2 plus 8 is 10. Negative 3 minus 1 is negative 4. And then simplify. Both of these are even. I know I can take 2 out. So 5, negative 2. Here's my slope. That would be the same way as if I chose y2 to be in front instead of y1. Last one here on this page says find the slope between 12.5 and -3, -25. Again, I'm going to label my points x1, y1. x2, y2. I'm going to start with this, so I can say negative 25 minus 5. And then I have negative 3 minus 12. So negative 25 minus 5, negative 30. Negative 3 minus 12, negative 15. Negative divided by negative makes it positive. 30 divided by 15 is 2. So I'm going to, and it's positive 2 now, instead of just saying 2, it's going to be a lot easier for me to graph and do everything I need to do with slope, keeping it a fraction, because remember that what this does is it tells me my rise is 2, my run is 1, so I want to keep it as a fraction. But here's my answer, 2 over 1, simplified. Okay, again, you can feel free to try this in the other order. I did y2 minus y1 and x2 minus x1. But if you do the same thing as y1 minus y2 and x1 minus x2, you'll get the same answer. Or you should, if you do it correctly. Okay, so that's how we can do that with finding the slope between 2 points. We can also find the slope from a table. Okay, and here's the thing. How many points do we need in order to find the slope? Just 2. What does the table do? It gives us more points than we need. So we really shouldn't have an issue finding it or finding a slope from a table. You can choose any 2 points that you want. You could also find it kind of the same way that we found rate of change in our last section. Okay, as I look between my x's, how do my x's change? Well, it goes from negative 3 to negative 1. What's the difference? The difference is 2. Goes up 2. So look at my y's. It went from 18 to 14. What happened? It went down 4. Okay, I can do that for multiple points if I wanted to. How does this change? It goes from negative 1 to 1, it went 1. How does this change? It went down 2. How did this change? It went down 6. How did this change? It went up 3. Okay, so as I compare how my y's change to my x, I get negative 4 over 2, which simplifies to negative 2. I got negative 2 over 1, which simplifies to negative 2. I got negative 6 over 3, which simplifies to negative 2. Should be a constant, right? Just like our rate of change was in a line. Okay, so how many points are we given? We're given 1, 2, 3, 4 points. How many points do we need? We only need 2. Okay, we didn't need to do this 3 times. I just wanted to show you that it was consistent. It didn't matter which you chose. Okay, so our slope, like we said, negative 2. We could also say, for graphing purposes, negative 2 over 1. Either one, it works out. Okay. On the other side, we have the same situation. Again, we don't need to do that a bunch of times. I'm going to do it just the times that I choose here. So here I'm going to say, hey, I got just a bunch of positive numbers. I'm going to choose this one. How does my x's change? Well, it changes going up 3, positive 3. How do my y's change? It changes going up 4. Okay, and so I have my slope of 4 over 3. Which again would be the same thing as if I chose any other point, right? If I chose between these 2 points, negative 6 to 10, I'd say how much does that change by? It changes by 16. It goes from negative 6 to 10. Okay, from negative 9 to 3, how much does that change by? Well, it changes by 12. So here I would have 16 over 12. Simplified, I can take 4 out of both of these. Simplified, that gives me 4 over 3. Okay, so same thing. Doesn't matter which points I choose to use. Okay. And now our final way, not really final way, but our final way to find slope from a graph. So as we look at these graphs, remember that we can find the slope using rise over run. And that's basically restricted to graphs as we do it. So in graph 1, as you see, as you go from left to right, the line goes down. Notice that this is a downward slope. So remember that we talked about that in last chapter, that means that the slope is negative. Right, that negative in front of x told us that it was a falling line. So it's a negative slope. So as we look at this, we go from our point, which is 0, 3, I'm just marking it, that's you have to do this, to the point 3, 1, or 1, 3, nope, 3, 1. Okay, and so we say, how much is our rise? Well, our rise from here to here, it went down 2. From here to here, it went 1, 2, 3. Rise over run, negative 2/3. As we look at this next problem, and we have 3 points to choose from. It doesn't matter which ones we choose to use. I'm going to use this one to this one. Okay, so I'm going to look at in this graph, as you go from left to right, the line goes up. So the slope is positive. And so our slope, so we look at our rise, it goes from 1 to 3, so it goes up 2, goes from left to right, over 1. So that slope is 2 over 1, or 2. Okay, remember that in our graph, when it goes up, it's positive. When it goes down, it's a negative direction. When it goes right, it's positive. When it goes left, that's in a negative direction. Okay, so that's how you can keep that straight in your mind. Okay, notice also in this graph that if we went from here to here, we could go down 2, and then to the left 1, and then we would have got negative 2 over negative 1, which simplifies again to being a positive 2 over 1. Because negative divided by negative is positive. So again, it doesn't matter which lines you choose or which points you choose. If you do it correctly, you will get the right answer. All right, here we go. Some special cases here, vertical and horizontal lines. Okay, so as we look at this red line here, it says write any 2 points from the red line, find the slope. So as we look at the red line, 1 point here would be 0, 3. 1 point here would be, looks like 3, 3. Okay, and so 0, 3, 3, 3. If we plug this into our slope formula, y minus y, 3 minus 3, y2 minus y1, and then x2, 3 minus x1, 0. And so we get 3 minus 3, which is 0, and 3 minus 0, which is 3. And that simplifies to give us 0. Okay, what's our slope of a horizontal line? 0. Okay, looking at the green line, write any 2 points. So here we have negative 1, 0, and negative 1, 3. So as we look at this, I have negative 1, 0, and negative 1, 3. So y2, 3, minus y1, 0, over negative 1 minus, oops, not a comma, negative 1 minus negative 1. So minus a negative is plus 1. And so 3 minus 0 is 3. Negative 1 plus 1 is 0. If you type that into your computer, you'll see that that's our computer calculator. That'll be undefined. Okay? Or sorry, undefined. It might say domain error. Okay? But when you divide by 0, what we'll call it is undefined. Okay. And so what is the slope for a horizontal line? The slope of a horizontal line is 0. All the time. Every line that goes horizontal, that slope is 0. What is the slope for a vertical line? That slope is undefined. You might even see it referred to as no slope, because we can't divide by 0. Okay. All right, so there you go. Rate of change, slope, very similar. You'll see that slope is just rate of change without the labels. Okay, so if you can do this, this will be a good step in, an important step into you being able to graph functions. Okay, see you.